If you are struggling with your lesson in limits of functions, this video walks you through exactly what you need so you can graph and solve limits in minutes or less, step by step. Hello Math Wizards! This is Joanna Calo, your Math Master from Group 2 Section Navarro. And in the next minutes, you will learn the discovery of limits in calculus, how we involve it in our daily lives and community, solve problems involving graph of piecewise function, finding limits using graphical approach, limit theorems, and indeterminate form, and finally, give you some handy tips to carry forward as a future basic calculus learner. So what are you waiting for? Buckle up for a worthwhile discussion. Today, we are going to learn about the concept of limits. But before that, let us first know what is exactly a limit. A limit is a value that a function approaches to some value. In other words, limit tells us the value approaching as the function's inputs get closer and closer to some number. In our real-life situations, limits can be used to measure the temperature of a boiling water or even the speedometer of your car, as the value gets closer and closer to the infinity of a certain number. Well, limits are everywhere, and this is essential to the subject called basic calculus, wherein it helps the students to develop critical thinking skills in analyzing and interpreting formulas that are present in a certain topic. Hello Math Wizard! I am glad to welcome you back. In this SEM, we have a lot to learn, so sit back and enjoy the ride. Today, we will be learning the history of limits. First of all, a limit is a value to which a variable quantity gets as close as possible. In the 3rd century BC, Archimedes of Syracuse invented the concept of limits to measure curved figures and the volume of a sphere. The needed quantity can be obtained by carving these figures into little parts that can be approximated, then increasing the number of pieces. Archimedes discovered the sum of a geometric series in such a way that he demonstrated his understanding of limits. He also calculated pi, discovered the area under a curve using the sum of infinite rectangles, and estimated the volume and surface area of a sphere, among other things. Whoa! So that's what happened. But it didn't end with that. The method, Archimedes' thesis, remained lost until 1906 when mathematicians found that Archimedes was on the verge of finding infinitesimal calculus. Others established a contemporary mathematical concept of limits since Archimedes' work remained unknown until the 20th century. Although Archimedes first touched the concept of limits back in his time, it wasn't until the 17th century that the modern idea of a limit was defined. Bernard Bolzano in 1817 was the one who set framework for being able to identify continuous functions, but sadly, he did not gain recognition for his work while he was still alive. The next development was then made by Augustin Louis Cauchy, who published his book Cours d'Analyse back in 1821 that talk about variable quantities and infinitesimals related to limits. After, Carl Weierstrass in 1861 introduced the limit and limit x approaches to zero notations, while Godfrey Harold Hardy was the first to place the arrow below the limit symbol back in 1908. All of these legendary math wizards from Bolzano to Hardy were also inspired by the works of Sir Isaac Newton and Gottfried Leibniz, who most will assert have discovered calculus. Quite amazing, isn't it? Due to the different discoveries of these brilliant mathematicians, limits now allow us to solve equations with real, full-bodied numbers instead of negligible values. The modern-day concept of limits is now used in different fields, from measuring speed and velocity as one travels in a car to counting time. Application of limits, Mindanao context. Limits is defined as a value that a function approaches the output for the given input values. Limits are important in calculus and mathematical analysis and are used to define integrals, derivatives, and continuity. In real-life situations, application of limits can be seen and utilized at any place. For example, due to the ongoing pandemic, the third Mindanao Art Exhibition, Mindanao Art 2021, that happened in Davao City and started to open on October 1 to October 31, 2021, is only limited to those who pre-registered, and only a maximum of 100 people are allowed to enter every 2 hours interval. Aside from that, some public transportation in Mindanao limits the number of passengers who can ride. The concept of limits is utilized in the examples because it makes it easier to control the number of people who enter the exhibition and those who ride public transportation. Furthermore, with the concept of limits, it will be a great help for the frontliners to easily track down the population in case someone is infected by the ongoing virus. With that, rules and limitations are set to make it more accessible and safer for citizens. In addition, if you find some examples of limits, they are commonly applied to sciences and fields that have mathematical applications involved. But not all the time limits can be applied in those. We could actually utilize the concepts of limits in our daily life. Some other examples are the dosage of the medicine, the food we intake, and the speedometer in our cars. Therefore, through limits we could predict, determine, and control the behavior of a function at a particular point. To better understand the limit, we have a solution set in each category. Each category has a corresponding topic. In each topic, you can guess what is the answer to a given solution set. So be ready, MathWiz learners! Be prepared as we start to conquer the limit world. Graphing piecewise function. Let's solve this problem. F of x that is equal to 2 minus x if x is less than 0, and that is equal to x squared if x is equals to 0, that is negative 6. If x is greater than 0 but less than 4, and this is 1/2 x squared minus 5 if x is greater or equal to positive 4. This function consists of 4 pieces. To graph this piecewise function, we must follow the steps. Step 1. Make a table values for the first piece. 2 minus x if x is less than 0. The x values should be less than 0. Specify the coordinates of the endpoints of the interval, if it is a solid point, a hollow point, or an arrowhead. For the first piece, let us find the values less than 0. 0, negative 1, and negative 2. So if x is negative 2, let's just plug this in. 2 minus x equals 2 minus negative 2 equals 4. If x is negative 1, then 2 minus x equals 2 minus negative 1 equals 3. And for 0, of course, 2 minus 0 equals 2. For the coordinates, let's put them in the ordered pair. The x is negative 2, the y is positive 4. For negative 1, the x is negative 1, the y is positive 3. For 0, the x is 0, the y is positive 2. Negative 2 is an arrowhead, while 0 is a hollow point. Step 2. Make another table of values for each of the remaining pieces and don't forget to specify the endpoints. For the second piece, we have x squared if x is equal to 0. If the value of x is 0, we have 0 squared. The coordinates are 0, 0, and its type of endpoint is a solid point. For the third piece, we have negative 6 if x is greater than 0 but less than 4. The values of the left side of positive 4 are 4, 3, 2, 1, and 0. If x is 0, it's a negative 6. Same for 1, 2, 3, 4, they're all negative 6. For its coordinates, put them in ordered pair. The x is 0, the y is negative 6. For 1, the x is positive 1, the y is negative 6. For 2, the x is positive 2, the y is negative 6. For 3, the x is positive 3, the y is negative 6. For 4, the x is positive 4, the y is negative 6. 0 is a hollow point, and 4 is also a hollow point. Step 3. Plot the coordinates obtained in Step 1 and connect the points. Here in the fourth piece, we have 4, 5, and 6. If the value of x is 4, it is equals to 3. If the value of x is 5, it's 7.5. And if the value of x is 6, it is equals to 13. Here are its ordered pairs: 4, 3, 5, 7.5, 6, and 13. The 4 is a solid point and 6 is an arrowhead. Step 4. Repeat the process until all pieces are graphed into one Cartesian plane. For the graph, let us plot all the coordinates obtained in the first piece, second piece, third piece, and the fourth piece. Here's our graph, and here's a more detailed graph. Graphical approach. Step 1. First, using the graph, let us know the left-hand limit and the right-hand limit. The left-hand limit is x approaching to c from the left, denoted by limit of the function f of x if x approaches to c to the left equals L. While the right-hand limit is x approaching to c from the right, denoted by the limit of the function f of x if x approaches to c to the right equals L. Step 2. As we already know the left-hand limit and the right-hand limit, let us identify the limit of a function of limit f of x as x approaches to 0 and limit f of x as x approaches to 4, and identify whether they are two-sided or one-sided limit. Here in the graphical approach, we use the same graph in the graph of the piecewise function. Let's try this. Limit of the function f of x as x approaches to 0 to the left. Now in this case, we will draw a graph of a function of x is equals to 0. So if x is equal to 0, we will be looking into the left-hand limit and the right-hand limit. We will be considering the left-hand limit because 0 is in the left-hand limit. So what would be the value of y as x approaches to 0? The graph of a function is approaching to this coordinate 0 and positive 2. So basically, as the value of x approaches to 0 from the left, and the value of y is equal to positive 2. Therefore, the limit of the function f of x as x approaches to 0 to the left is positive 2. Limit of the function f of x if x approaches to 0 to the right equals negative 6. What is the limit of the function as x approaches to 0? Now in this case, is the limit of f of x as x approaches to 0 to the left is equal to the limit of the function f of x as x approaches to 0 to the right? No, because positive 2 is not equal to negative 6. Now this limit does not exist because limit of x as it approaches to 0 from the left and right is not equal. Therefore, the limit of the function f of x as x approaches to 0 does not exist. Now, what would be the function value of f times 0? What solid point did our vertical line pass through? So our vertical line passed through the point 0. Therefore, f times 0 is equal to 0. Limit of the function f of x if x approaches to 4 to the left equals negative 6. Limit of the function f of x if x approaches to 4 to the right equals 3. Limit of the function f of x if x approaches to 4 does not exist because the limit of x as it approaches to 4 from the left and right is not equal. F times 4 equals 3. Therefore, both limits of a function are one-sided since the left-hand limit and the right-hand limit aren't equal. Limit theorems. Evaluate the following. Limit of the function 2x squared plus 4x minus 7 if x approaches 2. Step 1. Separate the terms as according to the sum and difference rules. Limit f of x as x approaches to c plus g of x equals limit f of x as x approaches to c plus limit g of x as x approaches to c, and limit f of x as x approaches to c minus g of x equals limit f of x as x approaches to c minus limit g of x as x approaches to c. It is 2 limit x squared as x approaches to 2 plus 4 limit x as x approaches to 2 minus limit 7 as x approaches to 2. Step 2. Using the concept of the product of a constant and a function where limit k times f of x as x approaches to c equals k times limit f of x as x approaches to c, factor out 2 from limit 2x squared as x approaches to 2, and 4 from the limit 4x as x approaches to 2. It is 2 limit x squared as x approaches to 2 plus 4 limit x as x approaches to 2 minus limit 7 as x approaches to 2. Step 3. Following the power rule where limit x approaches to c as x is equals to c, and the constant rule wherein limit k as x approaches to c is equals to k, replace the values of x with 2. We have 2 limit times 2 squared if x approaches 2 plus 4 limit times 2 if x approaches to 2 minus limit 7 if x approaches to 2 equals 2 times 2 squared plus 4 times 2 minus 7. Step 4. Simplify the expression. 8 plus 8 minus 7 equals 9. Therefore, the limit of the function 2x squared plus 4x minus 7 as x approaches 2 is 9. Now, let us try solving limit involving an indeterminate form. Evaluate the following. Limit x squared minus 9x plus 20 over x minus 5 as x approaches 5. Step 1. First, let us try to find the limit of the function using direct substitution property to confirm whether the limit has an indeterminate form or not. To do this, substitute 5 to all values of x. 5 squared minus 9 times 5 plus 20 over 5 minus 5 equals 25 minus 45 plus 20 over 5 minus 5 equals 0. This equation shows us the indeterminate form. Step 2. Since we have confirmed that the limit in the indeterminate form, we have to evaluate the given function. The given function is rational, therefore, we can try factoring the numerator. Limit x squared minus 9x plus 20 over x minus 5 as x approaches 5 equals limit x minus 5 times x minus 4 over x minus 5 as x approaches 5. Step 3. After factoring the numerator, we can see that there is a common factor, x minus 5, which can be cancelled. In limit x minus 5 times x minus 4 over x minus 5 as x approaches to 5, x minus 5 and x minus 5 can be cancelled. So we cancel them and we have it there left, limit x minus 4 as x approaches to 5. Step 4. After eliminating the common factor, we are now left with limit x minus 4 as x approaches 5. Use the difference rule to find the limit. Limit x minus 4 as x approaches to 5 equals limit x as x approaches to 5 minus limit 4 as x approaches to 5 equals 5 minus 4 equals 1. Therefore, the limit x squared minus 9x plus 20 over x minus 5 as x approaches 5 is 1. Now that we have finished the activities, let us have a few tips for our MathWiz learners. Tips to future basic calculus learners. Hey there, future math wizard! Here are tips for you to prepare as a newbie wizard in basic calculus. Now, let's hop into the wizard world. First, listen very carefully to your teachers and to lecture videos. Take good notes where you can remember the topic. It helps you to understand and familiarize the equations more. Second, in solving, familiarize the theorems or make flashcards. Flashcards is a way to go when you want to speed up your learning, especially in solving. Third, aside from writing a graph from a paper, you can make a graph in a math-friendly app like Desmos, GeoGebra, and more. Fourth, get ahead in your homework. Do answer your homework right away as this takes time and energy. Better to put basic calculus to your to-do list first. Don't ever procrastinate. Fifth, asking for help from your classmates and teachers is okay. It's good to find people who you can ask questions with things you are confused about. Pick the right circle of friends, form study groups or meets as this can motivate you to answer, since you have company. Sixth, Review your notes at least 2 or 3 days before your test. This will help you answer the test without worrying. Good study habit means good grades. Don't cram. Lastly, don't overwork yourself, Math Wizard. When you feel burnt out, it's okay to rest and rise up again. And that's it. Basic calculus is fun when you deeply understand how to do it. Sooner enough, you'll be an expert and we can't wait for it. Till next time, newbie Math Wizard!